Any questions with regard to the previous session on this sequences chapter? What we did yesterday? And I have given one posting, the problem which you have asked, that 1 plus 1 by n whole power n equals to e, the limit value, how it comes. It is just like applying monotone convergence theorem. The procedure is there. I hope that everyone has taken a look on that. Okay. Have you seen that? The solution part? All right. So coming to today's session, my intention is I want to take one problem on monotone convergence theorem, which is taken from the previous year questions, I hope. And later, I want to take some problems on the Cauchy theorems. Then I wish to discuss about the definition of Cauchy sequence and problems based on that. So that I have wished for today's session. The objective of today's session is like that. Okay. Right. So shall we start? If you have any other queries, you can ask. Right. So just hold on a moment. I will take that problem based on the previous series. Yeah. The question is, I have taken two positive distinct real numbers, a1, b1. I am saying that a1, b1 are two distinct positive real numbers. And I am defining two sequences, an and bn, as an is equal to half into an minus 1 plus bn minus 1, and bn is equal to square root of an minus 1 into bn minus 1 for all n greater than or equal to 2. So these are the sequences I have defined by this recursive formula. Now the task of the question is, we have to prove that these two sequences are convergent and they converge to the same limit. That was the question. Okay. Is the question and objective is clear? Yeah. Now we are applying the technique of monotone convergence theorem here. So on the whole, what we are doing is, since I can take any two distinct numbers a1, b1, we don't know which is big and which is small. So let us assume that a1 is greater than b1, because he didn't mention that this is small and this is big. And using the recursive formula which is defined for the given sequences, I should be able to show that each of the sequence an as well as bn is a monotone sequence and they are bounded. Hence, as a consequence of the monotone convergence theorem, they both become convergent, and one part will left others that if you calculate the limit, they will have the same limit that we need to show. Okay. Now, if you look at the definition of these two, one is nothing but the average. We can call it as the arithmetic mean, right? The other one is geometric mean. Could you agree? So let us take two numbers randomly. If you compare that, always arithmetic mean is greater than geometric mean. You can take any two numbers, that is evidently true. So what happens? From the definition of the sequences, we can say that an is greater than bn for all n. That is the fundamental step we write. Since arithmetic mean is greater than geometric mean, always an is greater than bn for all n. If you have a little doubt, you start building the sequences on your own. You take a1 is equal to one number, b1 is equal to another number, and we can start proving that. What is the corresponding terms of the sequences that we can find? Okay? Right. Are you getting that? Yes or no? Yeah. So, I am going to take the formula of an. So, my intention is I want to show them as monotone first. So, if I write an plus 1, from the definition of the recursive formula, it is half into an plus bn. Since we know that an is greater than bn, so we can write that this will be less than half into accepts this one from this step. So it is nothing but an so what you got here, an plus 1 is less than an. Yes or no? In other words, an is greater than an plus 1. So what happens? Observing this pattern, what can we say about an? Is it increasing or decreasing? An is greater than an plus 1. Decreasing. So the sequence an is a decreasing sequence. Now let us come for bn also as well. So we can write that from the recursive formula of this, bn plus 1 is equal to square root of an minus 1 dot bn minus 1. So here we can say that it will be greater than square root of Agreed? Please check that. Using the same pattern here. Yes or no? Any queries for anybody? If you have a doubt, let us read from the last. So forget about the symbols. We can write bn as root of bn into bn. Since an is greater than bn, you can write that this square root is bigger than this and it is nothing but bn plus 1. Accepted? So the logic here is bn is less than bn plus 1. Therefore, bn is a decreasing sequence. Sorry, increasing sequence. So by simply observing the nth terms, we have decided the monotoneness of the sequences. The first one is decreasing and the second one is increasing. Now we have to prove that they are bounded. Since an is decreasing, it has the upper bound already. Now the other part left with it is it must have the lower bound. So we have to determine the lower bound of an, right? So again we consider the recursive formula. So can I make space here? Right. So take the value of an. This is half into an minus 1 plus bn minus 1. Using the same technique here, we can write it as because an minus 1 is greater than bn minus 1. So this is nothing but bn minus 1. So what you got here, an is greater than bn minus 1. So here what happens, you have known the nature of bn already. It is an increasing sequence. So you can say that what is the smaller one for bn minus 1? Is it the previous term or the next term? Because bn is increasing. So the pattern of bn is like this. This is the pattern of bn because bn is increasing. So what is the number which is smaller than this? In other words, bn minus 1 is greater than what? Bn minus 2. Accepted? Yeah. So again, if you compare the next one, it is greater than bn minus 3. And so on. If you talk of that, you can go with b1. Right? So the ultimate result which you got here is an is bigger than b1. Why I have taken this relation here? I already known that an is a decreasing sequence. My intention is I must show it is bounded. Since it is decreasing, the upper bound is nothing but the first term. I should know the lower bound. So for this, by using the recursive formula technique, using the fundamental inequality what I got here, I have constructed this thing. Accepted to all? Right. So what is the lower bound of the sequence an? b1. So the sequence an is a bounded sequence. Similarly, by using the same recursive technique, by taking this formula, we prove that bn is also bounded. So please take a note of this. Now I am going to use this recursive formula. Yeah. Here an is decreasing. Earlier we have considered. Yes or no? Right. So decreasing means, how do you write the terms? In this way we write. And what you have observed here, an is greater than b1 for all n. It means that whatever the term you take in the sequence an, it is always bigger than b1. So what could be the lower bound? b1. That's why the sequence an is bounded. Right? Yes or no? Are you getting? Right. So I will erase this part again. May I? Now take this one. Again, using the same technique here, we can write it as the root of an minus 1 into an minus 1. Now what happens? You obtain that Bn is less than an minus 1. Since an is decreasing, what is the bigger one than this? An minus 2. What is the next bigger one? An minus 3, and so on. Ultimately, you will get a1 here. Please check that. Because an is the decreasing sequence, we can write like this. So the final output here is Bn is less than a1 for all n. Since Bn is increasing, we will write the terms of Bn like this: B1 less than, B2 less than, B3 less than, so on. So obviously the first element is the lower bound. So for the upper bound, here we have shown that Bn is less than a1 for all n. So the upper bound of the sequence is nothing but a1. Therefore, the sequence Bn is a bounded sequence. Fine. Any questions, please? We are just using the recursive formula to get the bounds. Right. Now, from the monotone convergence theorem, both the sequences are monotone and both the sequences are bounded, hence they are convergent. So you have done with the problem. There is one part left, that you should prove that both the sequences will have the same limit. That we need to show. So can I erase this? Right? So let us take that the two sequences will have the limits. Say the sequence an converges to the limit L and sequence Bn converges to the limit L. Now let us write the definition of an plus 1 one more time. So since an tends to L, an plus 1 also tends to L. Accepted? And let us take that this is L1 and this is L2 for a difference. Now from this relation, again we say that so if you apply limit for this one, so this implies that 2 into L1 is equal to L1 plus L2. So we need to understand that since the sequences are positive, if you calculate the limits are also positive. You cannot get a negative limit there. So to satisfy the equation obtained there, the only possibility is L1 is equal to L2. Therefore, we say that both the sequences will tend to the same limit. That was the conclusion. Okay. Yeah. So take a note of that. So this is one previous year question problem. So let us move some problems on the results which we have specified earlier. And I will give you one more problem on the previous year questions based. So you can take that. You take a sequence u1 is equal to root 7 and un plus 1 is equal to root of 7 plus un. You define like this. And you should prove that the sequence converges to positive root of x square minus x minus 7 equal to 0. You take this problem as a practice. Similar kind of problem we already done in the class. Right. You take a note of this. So this is the problem. Prove that limit n tends to infinity equals to 1. So let us have the interactive. First, let us discuss that on seeing the problem based on the previous results, what we have known, what is the result we need to apply here. Because I am taking the problems based on the previous results, what I have given to you as the notes. So on seeing the first look at the problem, how to decide that this result I am going to apply here. I think it will be helpful now. Is it fine now? Yeah. Now let us have the discussion. Because apart from giving the solution directly, I just want to know that on seeing the first look at the problem, you should have a conceptual idea that I am going to use this result here for this problem. That is my intention. So on seeing the problem itself, what type of logic we are going to use here? I am saying that all the problems are based on the previous results only. Yes, that is correct. One is sandwich theorem. Any other guess apart from sandwich theorem? Because if I want to use sandwich theorem, I need to go for a construction. Because I am very poor at construction, let us assume I want to avoid that. What else I can do? What else I can do? If there is no option, I especially go with sandwich only, that I agree. 1 less than or equal to m less than or equal to n, the same technique I follow. Apart from this, can I do better? So the hint here is, if we have a sequence Sn which is tending to the limit S, then the average is also tending to S. This is also one result. The Cauchy's theorem on limits, I have given this as a result, right? Could you recollect that? Everyone. So I think that since I am observing the sum of the terms here, can I make use of this technique here or not? So the limit value is, I can say, just hold for a moment. If you calculate the limit, say Sn is equal to, so n by, yeah, you are going to get it as 1. Yeah, I think it is 1. Let us check, right? So if I want to apply this limit, I should know the nth term of the sequence. If I say that the nth term converging to the limit, then the sum of the terms converge to the same limit. So for this option, I am going to define the sequence as Sn is equal to n by n square plus n. Why I have taken that? If I want to make use of this average property, in the denominator I got n. But here in the problem, there is no n in the numerator. So I have taken n in the numerator so that if I apply this formula, the n gets cancelled in the denominator. Okay? Why I have defined the sequence in such a manner? Because from the pattern of the sum, you can simply observe that this is the nth term Sn. I slightly modified that by taking n by n square plus n. So this is my sequence Sn. So what happens if you calculate limit Sn by taking n as common, you will get the value as 1 by square root of 1 plus 1 by n. The limit value is 1. Accepted all? Are you getting that? If I calculate the nth term of the sequence Sn, right? So using the Cauchy's theorem on limits, the average also tend to the same limit. So if I calculate the average, it is nothing but limit S1 plus S2 plus so on plus Sn by n should tend to 1 using the same technique. It means that 1 by n into S1 means n by root of n square plus 1. S2 means n by root of n square plus 2 plus so on plus Sn means n by square root of n square plus n. So this is also equal to 1. So this is nothing but the given problem, right? Using sandwich theorem, we can solve the problem, no doubt at all. That is also correct. So once you know the results thoroughly, if all the theorem statements are well versed for you, then you can make use of them. So if you observe that the proof for this problem or solution for this problem is just 4 steps. Step 1, defining Sn, calculating the limit. Step 2, Cauchy's theorem statement, and you have applied. And step 3 or step 4, the final solution. That's it. Okay? Any questions, please? Right. So if it is clear, let us go with the other one. Can I? Any doubts for anyone with this problem? Because taking the input from you, I will move ahead. Right. So the next question here is, it is somewhat interesting. I think you have done it already. Maybe let us do it. Limit n tends to infinity, n power n this is my problem. Did we do it earlier? N power n by n factorial whole power 1 by n equal to e? I think not yet. Yeah. Now, if this problem is given to you, on observing this immediately, you should think what result I can apply here. So I have given the 4 or 5 statements earlier, the results or theorems, what you can call. So which will be applicable here? So if you talk of ratio test, then we have 2 things there. So if you talk of ratio test, the statement gives that you calculate Sn plus 1 by Sn, it must have the limit L, then limit value is less than 1, then sequence converts to 0. This is the statement of ratio test I have given. Accepted? Yeah. So here he mentioned that the limit of the sequence is E, not 0. Right? So you cannot use this test here. I think everyone is getting the concept. I hope so. And you cannot you cannot apply the result because sum is not there. I am not observing any sum there. So this result I cannot make use of here. So what can the other result I can make use of here? So can I speak like this? Is it comfortable for you in getting the conceptual idea when a problem is given to you how to solve? Right. That's good one. So we are going to use the formula Sn power 1 by n. So this is also one of the results from Cauchy's theorem, which states that if you calculate the ratio Sn plus 1 by Sn, the limit is L, then nth root Sn is L. In other words, Sn power 1 by n is also L. Accepted all? So how ratio test fails is nothing but L is equal to 1 case ratio test fails. So ratio test gives that if you calculate the limit, whenever the limit is less than 1, it is convergent. He is in the problem, he mentioned that limit of the sequence is E. We need to prove that. E value is greater than 1, right? So you cannot get limit value which is less than 1 as per the problem considered. That's why you cannot apply the ratio test case here. And in the statement it shows that if the limit is less than 1, obviously the limit of the sequence is 0, not any other number. The limit must be 0. The sequence must converge to 0 only. That's the statement of ratio test here. But he mentioned that the limit is E, not 0. That's why you cannot apply this technique here. Okay? Fine. So I am going to make use of that property, nth root Sn property. Can I? Fine. So in the nth root Sn, please understand that whenever 1 by n is there, by default we apply the technique nth root. So we have to define the sequence term as, or consider the sequence term as Sn is equal to n power n by n factorial. I am not taking the power. Power limit automatically come while applying the result there. So this is my sequence Sn, and this is Sn plus 1, n plus 1 whole power n plus 1 by n plus 1 factorial. Right? Now let us calculate the ratio there. Sn plus 1 by Sn. This equals to n plus 1 whole power n plus 1 by n plus 1 factorial into this one will come. Now we are going to simplify the terms there. So we can write it as and this will be written as, and that will be taken as it is. Accepted? Please check. Any questions for anybody at this step? So let us cancel the terms. N plus 1 gets cancelled, n factorial gets cancelled. The thing will remain there. So sorry. So if you common n here, n gets cancelled. Now for this ratio I am applying the limit. So limit of this part So since the limit of this ratio is equal to E, by Cauchy's theorem on limits, the nth root value limit is also E, the problem is complete. That was the task. Okay. So in exam, after calculating the limit part, we should mention that by Cauchy's theorem on limits, this value is equal to E. Whatever the result it is, if you are good enough to write the total result, it is okay. Otherwise, we just use the word by Cauchy's theorem on limits, this limit value is equals to E. That we should write. Clear? If it is noted, I will go for the other one. I think it is also given in the previous year papers. So on this nth root technique, many problems were asked in the previous year papers. This is one among them. I can say that it is convergent. He simply mentioned like this. Is convergent. He didn't mention the limit. He has given like this. So 3n factorial whole divided by n factorial whole cube whole power 1 by n. This is my sequence. If you want a sequence pattern. So please take a note of it. Since whole power 1 by n is there, we use the same result here. So how to define Sn here? Sn is 3n factorial by n factorial whole cube. So if you write Sn plus 1, it is nothing but 3n plus 3 factorial by n plus 1 factorial whole cube. Accepted? Now let us calculate the ratio as it is. If you write this value 3n plus 3 factorial, so 3n plus 3 into 3n plus 2 into 3n plus 1 into 3n factorial whole divided by, it is n plus 1 factorial whole cube. You can just write like this. Whole by, this is Sn. So 3n factorial now if you go for simplification, for n plus 1 factorial, you can write it as n plus 1 into n factorial. So you will get n factorial, n factorial, n factorial here. So n factorial cube gets cancelled and 3n factorial gets cancelled. So you can write it as 3n plus 3 into 3n plus 2 into 3n plus 1 by n plus 1 whole cube. Say, will you accept? Yeah. So in the numerator, for each bracketed term, you can take n as common. So n, so n cube will get cancelled. You can take n as common here. So 3 plus 3 by n, 3 plus 2 by n, 3 plus 1 by n, whole by 1 plus 1 by n whole cube. So if you calculate the limit, so denominator value is 1. In the numerator, you have 3 into 3 into 3. The value will be 27. Please check. If I apply the limit, the value will be 27. Accepted all? Yeah. Now, as per the nth root Cauchy's theorem on limits, limit 3n factorial by n factorial whole cube whole power 1 by n. The limit is also 27. Since the limit is existed, the sequence is convergent. That was the conclusion. Okay. I want to take one more problem, similar kind of this. It is also asked in the previous year papers. So after taking a note of this, you please inform. Right. I think if we discuss like this, on seeing any kind of problem, we can immediately think that this is the strategy I am going to apply for solve this problem. I think it will be helpful. So the problem is given that prove that limit n tends to infinity this is the problem. N plus 1 into n plus 2 into so on n plus n whole divided by n power n whole power 1 by n. Is the top visible? So for this bracketed expression, whole power 1 by n you take equal to 4 by e. Right. So for this term, whole power 1 by n is there. So obviously, since whole power 1 by n is there, we are going to use of the technique Sn plus 1 by Sn. So you take that Sn is equal to n plus 1 into n plus 2 into so on n plus n divided by n power n. And yes, n plus 1 equals to n plus 1 into, sorry, n plus 2 into n plus 3 into so on. We are going to write n plus 1 in place of n. So it is coming as so please ask if you have a doubt in writing this term Sn plus 1. Yes, n plus 1 indicates that in place of n in the above expression, we are writing n plus 1. So the last term will be 2n plus 2. Since it is a product in the numerator, the previous terms are also taken into consideration. Could you agree? Any questions, please? Yeah. So if you write Sn plus 1, in this place, I am writing n plus 1. Right? So if you write n plus 1 here, it will become n plus 2. It will become n plus 3, so on. Actually, it is nothing but 2n. If you write n plus 1 there, it is 2 into n plus 1, nothing but 2n plus 2. If you observe, in the numerator, each one is the product. N plus 1, n plus 2, n plus 3, up to 2n values you are taking into product. So, if you take the product from n plus 2 to n plus 2, the previous values also come, right? So, that's why I have written that 2n into 2n plus 1 into 2n plus 2. That's why I have written that. Right? So here it is nothing but 2n. In place of that you are writing 2 into n plus 1. It is nothing but 2n plus 2. So you are writing the product starting from n plus 2 to 2n plus 2. So previous terms also will come in the numerator. The previous term is 2n plus 1. The previous term is 2n. I think it clarifies the doubt. Okay. Right. Now, as usual, calculate Sn plus 1 by Sn. So here it will come as n power n by n plus n. Straight away I am writing it as 2n. Now the terms gets cancelled here. So n plus 2, n plus 3 up to 2n gets cancelled. N plus 1 remain here. At this portion, if you common 2, n plus 1 will be here. So this n plus 1 will get cancelled here. So it will come as 2n plus 1 into 2 by n plus 1. This I am writing as, and this will be n power n by 1. Please check that. Any doubts? You can ask. All of you agree for the simplification? Yeah. So here I take n as common. So this n gets cancelled. Here I take n as common. So n power n gets cancelled. So there you can write it as 2 plus 1 by n into 2 by 1 plus 1 by n whole power n into 1 plus 1 by n. So this is the final simplified expression. Now if I apply limit Sn plus 1 by Sn, so if I apply the limit for this term, this will be 2, this will be 2, this limit value is 1, this limit value is e, so the answer is nothing but 4 by e. Please check that. So in the denominator, the limit of this term is e, the limit of this term is 1, here the limit is 2, so 2 into 2, 4, 4 by e will come. Accepts all? Right. So I have calculated Sn plus 1 by Sn, limit value is 4 by e. Therefore, by Cauchy's theorem on limits, limit n tends to infinity, Sn power 1 by n is also equal to 4 by e. So Sn power 1 by n is nothing but this whole term power 1 by n. This is also equal to 4 by e. That was the answer. Okay. So on our discussion, we can conclude one thing, that whenever the limit is giving as 0 and power n is there, you can make use of the technique of ratio test. Whenever the power contains the value 1 by n, you can make use of the technique, this Cauchy's theorem on limits containing power 1 by n. Another approach is, whenever the sum of the terms are given, then you can apply the technique of sandwich theorem or the Cauchy's theorem on limits, which gives the summation model. The algebraic mean converges to the same limit. If the sequence is given in the recursive formula mode, then we always make use of the monotone convergence theorem. That is the overall idea for getting a problem under sequences. Clear? So over the previous classes and today's class, we can conclude like that. As and when you see a problem, what is the approach in solving that, you can take this type of strategy. So any queries for anybody over this? If everyone is clear, then I am going to start a new concept, that is Cauchy's sequence. Right. So let us take the definition of Cauchy sequence. It gives that, just take a remembrance for the definition of limit. In the definition of limit, what you are saying, for epsilon greater than 0, you can find a term number m such that the sequence is becoming equal to L with a variation of epsilon. This is the limit of sequence, right? So for Cauchy's sequence, we define that for epsilon greater than 0, there exists m belongs to Z plus such that this is the definition of Cauchy's sequence. You can have the similar definition for Cauchy's sequence. The underlying idea is very simple, that if you list out all the terms of the sequence from a particular term number m onwards, all the values in the sequence are becoming equal. So there is no need of evaluating the limit separately. You are simply saying that all the terms in the sequence are becoming equal. You are saying like that. As and when the terms in the sequence are becoming equal, so that it is a convergent sequence. That is the notion. Fine. So the equivalent definition for it is, for epsilon greater than 0, you can write that modulus of S m plus p minus Sm is less than epsilon for all p belongs to Z plus. These two are same. So for Cauchy's sequence, you will have the three definitions. This is one, this is two, the other one I will give that. So all the three definitions are equivalent. You please take a note of this. Why the importance of Cauchy sequence is, since we have seen four strategies here, sorry, sandwich theorem, Cauchy's theorem on limits, monotone convergence theorem, and finding the limit by using the definition. These are the four strategies so far discussed in the chapter of sequences. Sometimes what happens, it is not useful, or it is very difficult to write the entire procedure in proving that a sequence is convergent. The properties of Cauchy's sequence says that every Cauchy's sequence, I will write like this, every Cauchy's sequence is convergent. Every Cauchy's sequence is bounded. Every convergent sequence is Cauchy's sequence. So these are the properties. So if you want to show that a sequence is convergent, the importance is not of limit, the importance is of convergence. It is simply say that the sequence is a Cauchy sequence. In other words, the sequence satisfies the Cauchy's criteria, because Cauchy's sequence, if and only if it is a convergent sequence. Okay, the result is Cauchy sequence is convergent, convergent sequence is Cauchy sequence. These are the two important theorems. Since we are not talking of the theorems, I am giving the statement. Every convergent sequence is Cauchy sequence. Every Cauchy sequence is convergent, every Cauchy sequence is bounded. So concluding these two, we can say that convergence if and only if Cauchy sequence. So if you want to show that a sequence is convergent, it is enough if you have proved that it is a Cauchy sequence. That's all. So all we need to do is nothing but just find a term number such that for the given epsilon, this is the term number, so that the values are becoming equal. That's it. Okay. Is this idea clear? Yes or no? Every bounded sequence need not be a Cauchy sequence. Let's say I have given the only 3 results. Let us take a problem on this also. I want to take some solved examples or problem examples that the sequences which are convergent, I am proving them as Cauchy sequence. The sequences which are divergent, I am proving them as not Cauchy sequence. Okay? That I am going to take some list of problems here. So on solving the problems, we will get an idea how the Cauchy sequence technique is useful in solving that. So please take a note of this, then I will erase. And this property, as in when you use in solving the problems, this we call it as Cauchy's general principle of convergence. If we use this expression, we call it as Cauchy's general principle of convergence. Right. So can I erase? Fine. So once you have done with a problem, then you will get the idea what it is actually. Now take the example sequence 1 by n. We know that this is a convergent sequence, yes or no? What is the limit? 0. Because limit n tends to infinity, 1 by n equal to 0. Everyone knows that it is a convergent sequence. Now I am going to prove that this is a Cauchy sequence. How I am going to prove? You take that the sequence Sn is equal to 1 by n and you take epsilon greater than 0. Please understand, epsilon is any small number. You can take 1 by 2, 1 by 4, 1 by 3, 1 as you wish. Generally not more than 1. From 0 to 1 usually we take. Now you take n greater than m. If you are able to say that what is the term number m, then you are done. It is just like the definition of the limit. So you consider mod Sn minus Sm. So it is nothing but mod 1 by n minus 1 by m. So this is equal to, since n is greater than m, 1 by m is less than 1 by m. So this is nothing but 1 by m minus 1 by n. So since you are subtracting some number from 1 by m, obviously it is less than 1 by m. Accepted? Yes or no? Are you getting it or not? Yeah. If I want to show that the sequence is a Cauchy sequence, I just have to specify what is epsilon and what is m. What is the significance of it? If I have started writing all the terms of the sequence from term number m onwards, whatever the terms you take, the difference between the terms is less than epsilon. That is the whole idea. Okay? Let us take in a simple manner. Suppose I have taken epsilon is equal to 1 by 2. So I have started writing the sequence 1 by n. 1, 1 by 2, 1 by 3, 1 by 4, so on. Now I have to mention that from this term number onwards, in this sequence, if you take any two values, the difference between them is less than 1 by 2. That I need to say. Okay? I think the concept is clear for everyone in proving this. So I have to specify the choice of epsilon and the term number m. Everyone agrees that? Okay. So this is the simplification. Sn means nth term of the sequence 1 by n. Sm means nth term of the sequence 1 by m. Since n is greater than m, 1 by n is less than 1 by m. So if you consider the difference, you are subtracting a big number from the small number. Since it is modulus, you can write it with a negative sign. So it will come as 1 by m minus 1 by n. Please understand, it is a number, it is a number. So obviously we can say that the result is always less than 1 by m because you are taking out something from 1 by m. So at this position, you choose epsilon such that 1 by m is less than epsilon. Why? Because this whole value Sn minus Sm is less than 1 by m. And if you choose epsilon such that 1 by m is less than epsilon, obviously this will become less than epsilon, so you are done. Okay? Yes or no? Suppose if you have a doubt how it is going to work. Now you tell me what is m, what is n. You give some numbers to me. Five comma 2. So you are saying that n is equal to 5 and m is equal to 2. So what is the importance of Sn minus Sm? It is nothing but 1 by 5 minus 1 by 2. Okay. I am substituting the values in the sequence because the sequence is 1 by n. Yes or no? Right. So it is nothing but 1 by 2 minus 1 by m because this is small number, this is big number. If you apply modulus, we will write like this. So if you simplify this, what is the value? 1 by 2 minus 1 by 5? 0.6, 3 by 10. Yes or no? Right? So this is 3 by 10. You are going to choose epsilon such that 3 by 10 is less than epsilon. So what could be the choice of epsilon there? Four? 0.4. You have to specify the term number, right? Okay, you have taken epsilon is equal to 0.4. It means that what? M is the term number. So here you have taken that term number is 2. It means that from second term onwards in the sequence, if you take difference of the two terms, that is less than 0.4, that you have taken. Fine. Does it make sense? Let us take one more problem. I want to take a set of problems on this, then you will get an idea how to choose epsilon and how to choose term number. By taking one more problem, we will discuss, because one example won't suffice. That's why I have mentioned that just get the idea of the limit definition of the sequence. For each epsilon greater than 0, we get term number m. In the definition of sequence, for each epsilon greater than 0, we get a term number m, right? Similarly, in Cauchy's sequence also, for each epsilon greater than 0, we should specify a term number. Or if you have taken a term number, you should specify the epsilon, vice versa. Okay? Right. Now take the example of the sequence 1 by n square. Sn is equal to 1 by n square. We know that the sequence converges to 0, say, accepted all. We know that it is a convergent sequence. Limit n tends to infinity, 1 by n square equal to 0. Now we prove that it is a Cauchy sequence. How? You take epsilon greater than 0. You calculate Sn minus Sm, where n is greater than m. Substituting the sequence values here. As you know, n is greater than m, n square is greater than m square. So 1 by n square is less than 1 by m square. So you are subtracting a big number from the small number. So what happens? The inside value of the modulus is negative. So while applying modulus, you should write like this. Since this value is always less than 1 by m square, because we are subtracting something from this. So what happens? At this position, we choose epsilon. So m is greater than 1 by root epsilon. Accepted? Yes or no? So what does it mean? If you take epsilon is equal to some number, say epsilon is equal to 1, then what will be m value? M should be greater than 1 by root epsilon, right? M should be greater than 1 by root epsilon. That means m must be greater than 1, because I have taken that epsilon is equal to 1. So what would be the value of m? 2, because m is a term number. It means that from second term onwards, if you take any two values in the sequence, the difference between them is less than 1. Is this acceptable? Just like we are finding a term number for each epsilon, in Cauchy sequence also we do the same thing. You take any two values in the sequence, you should specify the epsilon value corresponding to the term number. That's it. Then you are done. That's why I said if epsilon is equal to 1, what is root epsilon? 1. Right? So m is greater than 1 means m is equal to 2. M specifies a term number. That means from S2 onwards, every term in the sequence, whatever any two terms you consider, the difference is less than epsilon. First of all, let us write this. The sequence 1 by n square is nothing but 1, 1 by 4, 1 by 9, 1 by 16, so on. Accepted? There is the sequence what I have taken. Yes or no? 1 by n square sequence. Right. So this is first term 1. This is second term 2. So from this term onwards, in the total sequence, you take any two values, the difference between them is less than 1. That is what I am saying. If epsilon is equal to 1, from second term onwards, if you take any two terms there, the difference between them is less than epsilon. Could you check that? Take any two terms in the sequence, calculate the difference. Is it becoming less than 1 or not? You can find that, right? That's it. That is the idea of Cauchy sequence. I think that it will make sense. Let us take one or two problems, then we will have an idea, right? By taking more number of problems, we will get an idea what is a Kachi sequence in total. Yes, that is also right. But I am specifically, please understand, if you take first term as 1, I can take any term, right? You can take any two terms, not the adjacent ones. You can take any two terms. The difference must be less than 1. That is the idea. Sometimes slightly you can get equivalence. To avoid that, term number specification is most important. Not at all consecutive terms. You can take any difference. Second term, 10th term, that also you can take, right? That's why I said, just understand, if this is my sequence Sn, it is convergent. What does it mean? This is the convergent sequence. Accepted? What is the limit of the sequence there? 6. Yes or no? Because just what we are doing, if I have a sequence given, then you are simply checking that whether it is a Kachi sequence or not. If it is a Kachi sequence, it is convergent. We are not saying anything, etc. We are just saying that, and we are just verifying the condition of Kachi sequence. If it is Kachi sequence, by default it becomes convergent. That what I stated. Just say, earlier, if you want to say about the convergence, what you have done, you have verified the procedure. Monotone procedure, limit definition procedure, sandwich theorem, some results. Apart from all these results, what I am saying that the sequence has a special property. What is the property? The sequence is a Kachi sequence. What is Kachi sequence? For a given epsilon, I can find a term number in the sequence such that all the values in the sequence are becoming equal, so that it is convergent. That's all. That is the whole idea of Kachi sequence. Fine? Yeah. If I have written sequence, see, 1, 2, 3, 4, 5. This is term number 5. M is equal to 5 here. So what does it mean? This is S1, this is S2, S3, S4, this is S5, S6, S7, and so on. So what happens, since the sequence is a convergent one, the limit is equal to 6, we can say that Sn minus Sm is less than epsilon. You can fix epsilon. How that? Here the variation is, it is 6.1, it is 0.1. So epsilon is nothing but you can take 0.2. So for all n greater than 5, that means from term number 5 onwards, all the values in the sequence are becoming equal and with a gap of 0.2. Because I have written the sequence like that. Please understand. Okay? Because if you observe that from 5th term, 6th term, everything is becoming somewhat coinciding, right? So if you want to frame that, this is the condition. Because the gap between any two terms, at the most you take 0.2. Suppose you take this term and this term. So what it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is term number 6, term number 5, this is term number 11. This is less than 0.2. Accepted? Please understand, here we are not calculating the limit. We are saying that the terms are becoming equal. It is becoming stationary. It is becoming stationary. So it is limit existed. That's what we are saying as an outline. Right, I will take more number of examples. As one of our friends said that, take one problem which is not Kachi sequence. Let us take one more on that. The sequence which is not Kachi sequence, right? So you take that the frequently known problem, say, I will just say take the value -1 whole power n, the sequence. So this sequence is not convergent, we know, because it is oscillatory. -1, 1, -1, 1, the terms are coming like that, isn't it? Yes or no? So since it is not convergent, it is not Cauchy sequence. Suppose I have given a sequence, you don't know anything about the convergence, whether it is convergent or not, you don't know. You are just checking that it is a Cauchy sequence or not. So please understand, if you are proving it is a Cauchy sequence, for every epsilon, you should find m. I have epsilon 1, you should find corresponding term number. I have taken epsilon is equal to 1 by 2, you should find term number. I have taken epsilon is equal to 1, you should find term number, such that difference is less than epsilon. If it is not a Cauchy sequence, it means that I can find a term number m such that if I calculate Sn minus Sm, it is greater than epsilon. So for Cauchy sequence, this is the holding condition. For not a Cauchy sequence, this is the holding condition, right? Yes or no? Are you getting the concept? Yeah. So this is a sequence. I am proving that it is not Cauchy sequence. How? So I have given definition. You can take any definition. Sp minus Sq is less than epsilon for all p comma q greater than or equal to m. It means that you can take any two terms in the sequence. The difference must be less than epsilon, then it is Cauchy sequence. If it is greater than epsilon, it is not a Cauchy sequence. So what happens? Let us take that epsilon is equal to 1 by 2. If I am able to specify that in the listed sequence, I can find two terms, the difference is greater than this value, then I am done. Accepted? It is not satisfying the Cauchy's criterion, so it is not a convergent sequence. Yes or no? Are you getting it? Yeah. So let us go for it. So I am considering Sp minus Sq, right? So what are Sp minus Sq? P stands for term number P in the sequence. Q stands for term number Q in the sequence. So if I write the sequence, you can take any P, any Q. Suppose this is P and this is Q. You can take like that. Okay? You can choose any two terms in that. So for a idea, I am taking that, say, you can take P and Q as one even number, one odd number, say P is equal to 2m plus 1 and Q is equal to m. I am taking the two successive ones. So what happens? It is nothing but Sp means -1 whole power 2m plus 1 and Sq means -1 whole power 2m. If you calculate that, since it is odd number, I have taken the value as -1 whole power n. So this is -1 and this is -1. The result is 2, which is greater than epsilon. So the sequence is not a Cauchy sequence. So if you are proving that the sequence is not a Cauchy sequence, it means that if you take epsilon is equal to some number, any number, 1 by 2, 1 by 3, 1 by 4, anything you take, right? In the whole sequence, you can take any two terms. If the difference of the terms is greater than epsilon, means it is not a Cauchy sequence. So it is our ideology that what are the term numbers there which are violating the less than epsilon condition. That's it. If you are able to, yes, then the term number will be different. Please understand. If you take generally epsilon is arbitrary, very small real number. At the most, we take epsilon is equal to 1. 0, epsilon equal to 0 0.1, 0 0.2, 0 0.3, up to 1 usually we take. So let us say I have listed a sequence earlier, 6, 6.1, 6.2, 6.3. If you take epsilon greater than 1, yes, just understand. Is this part clear for you? Say. Yeah, just say one thing. I think you didn't get the concept of limit of a sequence. I hope so. Suppose I have written a sequence which is convergent. What is the meaning of convergent here? If I start writing all the terms of the sequence, from a particular value onwards, all are becoming equal with a slight variation. Isn't it? Yes or no? So it means that if I say that the limit of the sequence is say 10. So what does it mean? From a particular term number onwards, all the values are becoming equal to 10. Even though they are not equal to 10, there is a small gap. In this way, the sequence is going on. Yes? In this way, the sequence is going on 10, 10, 10, 10.1, 9.9, 9.9, 9.9, again 10, 10, 10, 10, like that. The limit is 10. So if you fix that, epsilon is equal to 1. So what does it mean? The sequence will come as like this. Can you say what is the limit of the sequence here? It is not becoming stationary. It is different values you are getting there. So what is the limit of the sequence in such a case if you write that? So if you say that the sequence has a limit L, it means that from a term number onwards, all the values are becoming like this. So you cannot take epsilon more than 1 generally. If you take epsilon 1, so if I say that 10 is the limit, if you take epsilon is bigger than 1, say epsilon is equal to 2. So what does it mean? All the terms in the sequence are becoming that 10 minus 2, 8, 10 plus 2, 12. So the values in the sequence are becoming like this. From 8 to 12, you can take any number. So 8, 8.1, 8.2, 8.3, 8.4, 8.5, 9, 9.5, 10, 11, 12, anything you can take. Now see the difference. Is it a convergent sequence? No. Because you are getting different real numbers, not a fixed real number. If you have a fixed real number, it is the limit, isn't it? So that's why here in Cauchy sequence, you are saying that from a fixed term number onwards, whatever the term you take here, you can take a term here, you can take a term here. The difference between them is less than epsilon. You are saying like that. That's it. That is the concept of Cauchy sequence. Okay? The whole idea is nothing but you are simply saying that all the terms in the sequence are becoming equal. They are becoming equal, you are saying that. When they become equal means it is becoming stationary, it is becoming stagnant. So it is convergent. That stagnant value is nothing but the limit. So here you are not finding the limit. You are saying that it is stagnant. That's all. Okay. So tomorrow also I am going to take more problems on this Kachi sequence. Problems based on Kachi sequence. Then the first chapter will be completed. Then we start the next chapter, that is infinite series. Fine. So with regard to examination point of view, on sequences chapter, we need to concentrate on Moulton convergence property and the problems based on results. And more weightage is given to the infinite series. Right? So majority of the questions are asked in infinite series. We will take with a lot care of that. So that is for today's session. You can ask if you have any other queries. I think you are a little struck with the concept of Kachi sequence, what it is actually. Right. The idea is nothing but you are proving any two terms difference. If you consider in the sequence, they are becoming equal. It is very small. Tomorrow I am going to take more number of problems on this Kachi sequence, right? In the beginning itself I will take. Yeah. That's all for today. We will meet tomorrow.